Good morning, Wake Tech. It's Dr. Roddenberry coming to you live from Willow Springs, North Carolina. Hope everybody's having a good morning. We are on day 2 of the Lectures for Psychology 150. Everybody's go ahead and check in and say good morning. I see AK1 is online. I see we've got John Ramos, Kristen Marie, and Sydney Burrows, and Becky Forsberg. How's everybody doing today? Good to see you. I forget, how many of you did we have in webinar last night? We had a really great webinar last night. 46 people attended. We had a great discussion about the different areas and subfields of psychology, and hopefully people learned quite a bit last night. I hope we have as good a crowd tonight in the webinar. Good morning, everybody. Fantastic. Becky's got her coffee. Got to have your coffee if you're going to teach in the morning. I found that caffeine and schoolwork really goes well together. Oh, good deal. Oh, Rebecca. Okay, right. I'm sorry, Rebecca. Would you prefer Becky or prefer Rebecca? Just whichever one you want, let me know. That's interesting. Okay, so hope everybody comes to the webinar tonight. There's nothing really to prepare for the webinar. Just maybe watch the video for this week's homework so we can talk intelligently about that. And come prepared to participate tonight. So any questions before I get started? Any questions before we get started in the lecture? Becky says, it's okay to go by Becky. I just have Rebecca in Teams for my professors. Fair enough. That's your official Wake Tech name. I like Rebecca. It sounds more professional anyhow. So why not? Let's go with it. Okay. Fantastic. Okay, we've got 8 people in the audience. Before we get started, I'm going to be talking about research methods today. If anything is difficult or doesn't make sense, I have got videos in the course resources folder, which are instructional videos, which will go back and pretty much repeat whatever I said, but it'll probably do it in a better way with images. So, steps in the scientific process. There's a cool video on random assignment and another one on experiments. So we're going to be talking about experiments today. If you don't quite understand today's lecture, you do have these resources in your course folder. Okay, looks like we're spun up to 10 people. Wow, thank you for coming. If you want, go ahead and check in on the chat bar and let me know you're here if you just stopped in. And if you want, you can select the subscribe button down at the bottom of your screen, and you'll always get alerts whenever I post new videos to this folder. So go ahead and do that. Holy cow, thank you very much, Sydney Burrows, for subscribing to my channel. I just got the announcement. Fantastic. So we're going to talk a little bit about the scientific process today. We're going to talk about descriptive research methods, correlation methods, and experiments. Okay. Welcome. Good to see you, Christina Bettini. Okay. Now here's the deal. Science needs theory, and theory needs science. So yesterday I talked about the Greek philosophers, and I suggested that they used their logic to try to guess the laws of human psychological functioning, and I told you can't quite do that. On the other hand, you can't just go around making observations. You have to have a reason and a plan for making observations. So you have to have logic and observation in the true scientific process. And so that's really what the research process is about. It's about using the logic and the observations together to learn more about the world we live in, generally speaking, and for psychology to understand how the mind works. So let's start out with this thing called a theory. A theory is a description of an observed phenomenon that explains the critical elements of the phenomenon and how they work together. The scientific process is a systematic process of testing and evolving theories. So let me give you an example of a theory. A theory is just an observation that tries to explain, is an explanation that tries to explain a bunch of observations. So we might know that people with high self-esteem do better in school. And you might ask the question, well, why does that happen? And I might come up with a theory that high self-esteem leads to success in school because it protects people from the negative impact of occasional failure. That's a theory, if you will. It's a description of an observed phenomenon, why people fail school, and it tries to explain the critical elements. Well, people fail in school because they have low self-esteem, and when they do poorly in school, they lose hope and they lose their confidence. That's an explanation of a phenomenon. And what a hypothesis is, it's an educated guess because your hypothesis is a statement about what you should be able to observe if your theory is true. If your theory is true. So if it is true that high self-esteem leads people to success because they don't give up when they fail, okay, what I could do is I could divide people into those with high self-esteem, those with low self-esteem. I could give them a project that's impossible to do, and I could measure how long it takes people to give up. And I might expect that people with high self-esteem don't give up as quickly as people with low self-esteem on an impossible task. And so what I have is a theory about high self-esteem and success, and then I'm going to set up an observation, if you will, where we can test that. If my theory is true, then people with the high self-esteem should persist longer in the impossible game than people who don't persist as long in the impossible game. So what we do in science is we come up with theories and then we test them by coming up with hypotheses, things we should be able to see if the theory is true. And as long as we keep supporting our hypotheses, these things keep coming true, then we can keep our theory. However, theories are only temporary. You at some point will do a hypothesis test that will show that your theory is wrong, incorrect, or limited. You will then have to change your theory and begin testing that new theory. So science is a process of developing theories with logic and then testing them with observation. Observation, logic, observation, logic, observation, logic. Does that make sense so far? Nobody's typed in the chat bar, and I want to make sure everybody understands what I'm talking about. So it's good morning, Ebony. So science is a process of logic and observation. All right. Now your book's going to talk about the 5 steps in the scientific process. This is pretty much the steps in the scientific process if you have decided that you are going to study something. So let's say I was interested in studying high self-esteem and its impacts on people's school performance. What I would do is I would formulate a theory, and you see it down below me. High self-esteem leads to success because it protects us from the negative impact of occasional failure. Then what I have to do is develop a concrete observable test where my theory can fail. If you set up a test where your theory cannot fail, then you're not doing anything. You have to set up a situation where the data might not support your theory. And this is where you develop a hypothesis, if you will. This is a hypothesis. Your book doesn't really talk about hypothesis, so I'm not going to talk about it that much. All right? Now, having developed this theory and a way to observe if this theory is true, we then have to pick a research method. And that's what I'm going to talk about today. We can pick descriptive research methods, we can pick correlational research methods, and we can pick experimental methods. And they all have different strengths and weaknesses. And we're going to then test our hypothesis using one of these research methods. And we're going to analyze the data, that is, compare the data among the groups to see if the data are in the pattern that our hypothesis would suggest. And then most importantly, we have to share these results by publishing them in a journal article that other professionals in our field will see. So just as there are 50 or so different subfields of psychology, I guarantee you there are at least 50 different journals, one for each subfield. And actually, there are probably 2 or 3 journals for each subfield, if not more, where people who are interested in that particular subfield can publish their research. And more importantly, the people who are interested in learning about research can go and read it. Because before you can start an experiment, you have to know what is already known. And we do that by consulting the existing literature. Okay, I hope that makes sense. I'm not looking at you in the face, so I can't tell if you're understanding it. Now, there are a couple of things to keep in mind. Your theory is only good if it is disprovable. If you can't disprove a theory, then you can't run a test and conclude that your theory might be true. Okay, so a theory has to be able to be shown wrong in order for it to be a scientific theory. Theories are always temporary. Now, some of your anti-science people, and I've noticed that some people who are hesitant to get the vaccine these days, are making a big deal about the fact that sometimes scientists change their advice. Well, the reason that scientists change their advice is because the data come in to suggest that we should change the theory. Okay? And so when a scientist is telling you something different, what they're doing is they're giving you a new theory based upon updated research. I don't know if you saw this, but I just read an article. They're now saying that it turns out, comparing people who got the 2 vaccines within 3 weeks like you were supposed to, and people who ran into trouble and didn't get their vaccines until 12 weeks, what they're finding is that the people who spaced their vaccines out 12 weeks apart seem to be more immune to the coronavirus than people who spaced their vaccines out 3 weeks, like the professionals said. So going forward, probably what you're going to see is anybody who gets the new vaccine will probably be asked to wait longer in between doses. Now, is that because scientists were lying to us before? No, it's just the original theory was that 3 weeks would be enough, and the data that have come out since people have been vaccinated have shown that maybe 12 weeks is better. So theories are always temporary. And you know what? A lot of the things that I tell you here today in 5 years or 10 years are going to be shown to be wrong or incomplete at best. So you have to understand that theories are always temporary. And also, it's incredibly important to publish your research. Sharing your research allows the community to grow their theories too. As I suggested to you, each subfield is going to have several different journals where people who do research can publish their findings, and the people who are interested in learning what the science knows can go to those journals and read those articles. And so publishing is probably one of the most important steps in the scientific process. Okay, do we have any questions so far? That's the scientific process. Now, there are 3 broad ways to gather data, okay, to make observations. We'll call these types of research methods. And these are just different ways of gathering observations. They have advantages and they have disadvantages. Okay, so if you'll look here, types of research methods right underneath me. We have descriptive methods, okay? And a descriptive method is nothing but simply going out there and measuring what's happening in the world, observing what's in the world. You can observe what people do. You can observe what people say. You can bring them into the lab and observe them in your lab. You can give them something to do and watch them do it. Or you can go out in the real world and observe somebody maybe without them even knowing that you're watching them. And these are all in what we would call the descriptive methods. Now, if you'll look underneath it, you'll notice that we've got the descriptive method divided into 3 sub-methods: observational studies, self-reports, and case studies. And we're going to talk about these 3 different kinds of descriptive methods. Now, you'll then notice beside that in the blue box are correlational methods. Correlational methods are when we measure two variables and see if those variables change in a pattern-like way. Okay, so here's an example of a correlation. The more cigarettes you smoke, the higher your likelihood of getting cancer is, right? So we could measure the number of cigarettes a group of people smokes, and then we could measure how often people in that group get cancer. And then we could measure these other group of people who smoke a different number of cigarettes every day, and we could measure how often they get cancer. So we're measuring two variables, and we're seeing if they change in a pattern. Does one go up while the other goes up, or does one go down while the other goes up? All right, and so that's a correlational method. And then the third method is what we'll call the true experiment. This is the gold standard for science and for psychology. And if you really want people to have faith in your conclusions, you need to run an experiment. But experiments are hard to set up, and you need to have great experimental control for a true experiment to work. And this makes it sort of difficult to set up. But this is the only method that can prove that something causes something else, to demonstrate causality. Okay, so I'm going to go ahead and talk about these in detail. Uh-oh, goodness me. Let me go ahead and cut my backdrop off for a minute, and then cut myself off for a minute. There you go. Observational studies. I'll have to disappear for a second till I get done. Now, in an observational study, which is one kind of descriptive study, a researcher creates a systematic process for making observations on the behavior of individuals of interest. Now, you can do an observational study in a laboratory, or you can do it in the real world, which is called a naturalistic setting. So you can bring people into your laboratory and you can observe and measure their behavior, or you can go out into the real world in a natural setting and observe their behavior. So if you look at the picture here on the side, this is a picture from one of the most famous developmental psychology studies in history. Mary Ainsworth ran what was known as the strange situation experiment. I shouldn't have called it experiment. The strange situation observation, really, is what it should be called. And she was looking at the bond that little babies have with their primary caregiver. And so she would bring people into the laboratory, and you see this baby is sitting in the laboratory looking up at with their mom in the black shirt there. And you'll notice that there's a stranger in the room. And you'll notice that the baby is carefully looking at that stranger. You know, babies are kind of scared of strangers. And then what Mary Ainsworth does over 10 minutes is she has the mom get up and leave the baby alone for 2 different times. Once with the stranger and once all alone. And then what Mary Ainsworth did was she observed how the baby reacted towards the mother when the mother came back into the room. And this is what's known as a laboratory observation. He brought the baby into the laboratory and he observed what the baby was doing. So you're going to see a lot of research studies in psychology that are observations. Studies of personality and how people's personality changes, study of infant attachment, studies of health psychology. A lot of these are going to be observational in their nature. Now, the advantage of the observation method is it's kind of easier to set up a situation and just observe behavior. And so the advantage of observational studies and descriptive studies in general is they're the good first place to start with start a line of research before you set up a difficult experiment. Now, you notice that the baby is in the lab here. Observation in the laboratory is different from observation in the real world or naturalistic settings. The main difference is that the person of interest knows they're being observed. But if you think about it, these are not the baby's natural toys, right? These are the toys that the experimenter had. This is not the baby's living room. And so what you're going to find is sometimes human beings will not act naturally if you put them in an artificial situation. And your book talks about reactivity being one of the main reasons they don't. It's because they know they're in a special situation or that they're being watched, and they may act differently. And that's called reactivity. However, in a laboratory study, you do have a little bit of control over the situation, what toys are involved, how far these chairs are from one another, exactly what the stranger does. So you're going to have a little more control, and control allows us to rule out other variables in our theory, but they also create a more artificial situation. So observational studies, one kind of descriptive method. Now we also talk about descriptive methods, which are surveys and self-reports. We're going to talk about a lot of surveys and self-reports in this class. Did you know that there's an actual personality scale we're going to talk about in chapter 10, which measures how easily you are able to form adult romantic attachments? It's called the Adult Romantic Attachment Scale. When we get to chapter 11, we're going to talk about stress. I'm going to ask you to take the Holmes-Rahe stress inventory. And so that's a test that measures how stressed out you are. And then in chapter 12, when we talk about personality, I'm going to give you the most reliable and valid online personality test in existence. The Big Five. And so we're going to measure your personality. Or you know what? There are lots of tests that measure psychological disorders. So you can give people the Beck's Depression Inventory or the Manifest Anxiety Scale or any other sort of personality disorder scale, psychological disorder scale. So another descriptive method I'm going to be talking about this semester are tests, and what tests have shown us about people's psychological functioning. Now, the cool thing with tests is they're really easy to hand out and to make up, right? Not good ones. Good ones are a little harder to make up, but you can make up a survey literally in the next 10 minutes and have people fill it out by handing it out to all the people you see. So it's a really good way to collect a lot of data really quickly. However, the problem with asking people about themselves is sometimes people tend to lie when they're talking about themselves. They tend to make themselves look the way they think you want them to look, or to look good in general. And these patterns of trying to manage what people think of them leads to this thing called self-report bias. And people really don't tell you the truth. And you know what? Sometimes they just don't remember accurately, or they don't know how they would act in a new situation. And so asking people about themselves sometimes has its disadvantages. Any questions so far? Now, the third descriptive methods are case studies. In case studies, we're going to talk about these from time to time in class, especially in chapter 2. Case studies are a descriptive research method that involves the intense examination of one person or one organization or maybe just a couple of individuals over a long period of time. So you can study one person in depth. Now, we do a lot of this in brain damage studies. People sometimes have damage to their brain. Well, we would never do that on purpose to somebody. But if somebody has brain damage and they have some really weird behavioral deficits, things they can't do, then we may study them in depth to find out exactly what's going on with them. And so unique cases of people with brain damage have helped us to really develop insights into how the brain and the nervous system works. You know what? When we get to chapter 5, I'm going to show you the case study of a boy that sees with his ears. Anybody ever heard of Ben Underwood, the blind boy who can see with his ears? Anybody ever heard of that guy before? I'm going to have you meet a guy who can see with his ears. What a crazy case study. Doesn't happen very often, but it tells us an awful lot about how the brain is wired together and how it wires itself together. Now, they allow us to study situations that would be unethical to study experimentally. So you can't go damaging people's brains, but if you find somebody who does have brain damage, you can study them to try and learn about their ability. You probably have. It's a great story, and you're going to like it when we get to it in chapter 5, John. Famous case studies. I don't know if you ever heard of Jeannie the Wild Child. She was actually raised in silence for the first 11 years of her life. She was raised by a crazy old dad in Los Angeles, California in the 60s, and he locked her in her bedroom from the time she was born until she was 11 years old. He wouldn't let anybody in the family talk to her. He kept her locked in a cage at night, an animal cage that she had to sleep in, and they would feed her through a hole underneath the door. And he raised her in total isolation for 11 years. Anybody ever heard of Jeannie the Wild Child? Now, you could never do this ethically to a person, but since it happened to Jeannie, when they found her at 11, she couldn't speak a language. She hadn't learned how to speak. And so they tried to teach her how to speak, and they studied and learned a lot about the natural elements of language development with Jeannie the Wild Child. And then HM had part of his brain removed because of seizures, a brain part called the hippocampus, and he was unable to learn anything new ever again. Not a person's name, not a store he went to, nothing. And so we learned an awful lot about the hippocampus from the case study of Ben Maliasen. Yeah, it's a crazy study about Jeannie the Wild Child. Now, correlational methods. All we do is we measure two variables and we can see how these variables relate to one another. Now, correlational methods require a little more control because we need to get not one measurement, but we need to get two measurements. And usually when you're making two measurements, you have to have the same person to make those two measurements. So you can't just go out into a field and watch somebody and they may walk off and you can't talk to them 2 days later to find out what they did. So with the correlation, we need a little more control. It's a little more difficult to set up, but we can now begin to say that one variable is related to another. With an observation, we can't really say that one variable relates to another because all we do is we measure single variables. In a correlation, we're going to measure two variables and see how they relate to one another. All right. And so what we're going to do is we're going to see if one variable changes in relationship to another variable. So let's go to the white pad real quick. And you know what I could do? I could get 1,000 people and I could ask them how many cigarettes daily, right? I could ask them, how many cigarettes do you smoke daily? And you know what? I would find that some people like to smoke. You know what? I screwed that up because I was nervous. I'm in front of you. Let me do that right. I could go and I could ask somebody, okay, let's see. Yeah, actually I got it right. How many packs a day? And then I could ask people to find out how many packs of cigarettes they smoke a day. Some people smoke 0 packs a day. Some people smoke 1 pack a day. Some people smoke 2 packs a day. My mom smoked 3 packs a day till the day she died, right? And then you know what we could do? We could do age at death, right? And you know what we might find? And this would be, let's say, 50, 60, 70, and 80. And you know what we might find? We might find that a lot of these people who didn't smoke any cigarettes lived a long time, okay? Except for Billy. He got run over by a bus at 50, okay? And then we might find the people that smoke 1 pack a day, and we might follow them, and we might find that, you know what? They tended to die in their early 70s. And then we might go talk to the people who smoke 2 packs a day for all their life, and we might find that they died in their 60s, and some of them even died in their 50s. And then the same thing with 3 packs a day. And do you see what you have here? You have a linear relationship where the more packs of cigarettes you smoke, the younger you die. Do you see that? The more packs of cigarettes you smoke, the younger your age is at death. This is what's known as a negative correlation. Okay? Does that make sense? Does everybody understand that? That's a correlation. All right? And then you know what we might do? I might measure your test grade on your first exam. And then you know what? I might ask you, how many hours did you study? Right? And so some people studied 0 hours, and let's say this is a 50 and this is a 100. And I might find that these people that studied 0 hours didn't make such good grades. People who studied 1 hour made pretty decent grades. People who studied 4 hours made hundreds, and people who studied 2 hours made in their 80s. And so I might see that the line kind of goes up. As one variable increases, the other variable increases. This is what's known as a positive correlation. Positive correlation. Okay? So, in a correlation, I'm simply measuring 2 variables of interest to see if they are related to one another. It's used when we cannot do an experiment. Now, I can't run a true experiment. If I really wanted to run a true experiment, what I would do is I would go find myself a bunch of 4th graders, and I would randomly assign half of them to smoke cigarettes, and I would compare them to half that didn't smoke cigarettes. Now, when I'm doing a correlation, I can't know what other variables are related to my 2 variables of interest, right? So if you go to my whiteboard study, you might see the number of hours a person studies seems to be related to the grade that they make. But you know what? Not only do they study longer, but you know why? Maybe they study longer because they have high IQs. Maybe they're high IQ people, and high IQ people know that you have to study in order to do well on a test. So is it the fact that they studied longer, or the fact that they had high IQs that determines the relationship between the number of hours studied and your grade? In a correlation, I can just demonstrate a relationship, but I can't say that your high IQ, that your number of hours studying causes your grades to get higher. I just can say that they seem to be related to one another. This is what's known as a correlational study, right? So remember I said earlier, it looks like people with high self-esteem tend to do better in school. Well, does their high self-esteem make them do well in school? Okay, so I feel good about myself, so therefore I don't give up when things get hard, right? We could say that, but you could just as easily say making good grades gives you high self-esteem, right? You come into school every day and your teacher tells you you're great, that's going to make your self-esteem get higher. So even though there's a relationship between self-esteem and high grades in school, does your self-esteem cause your grades to go up, or do your grades cause your self-esteem to go up? In a correlation, we really can't tell which causes which. We can only say that they are related. So one of the things that I want you to know about correlation is not causation. Okay? You need an experiment to demonstrate cause. Okay, does everybody get that? Everybody see that? Correlation is not causation. You need an experiment to demonstrate cause. All right, so let's talk about correlations. Oh, here are the correlations. Excuse me, I didn't flip to this screen early enough. This is an example of a positive correlation, a negative correlation, and no correlation, right? So the higher your impulse control, the higher your academic achievement. That's a positive correlation. On the other hand, when we get to developmental psychology, I'm going to tell you the more cardio you do, the lower your likelihood of developing dementia. So the more activity, the less dementia. So one's an example of a positive correlation and one's the example of a negative correlation. Now, in an experiment, experiments really are the only way to demonstrate cause. And we do that because we compare two groups of people that we feel very confident are similar at the beginning of the experiment. Now, let's say I'm interested in seeing whether or not how close you sit to the board determines your grade. I have a theory that students who sit in the first part of the class, front of the class, see the board better and will learn the material better than people who sit in the back of the class because they can't see as well. So I have a visual theory of learning. The closer you are to the board, the better you can see the board and the more you learn. And so what's going to happen is on the first day of class, students are going to walk into my classroom and they're going to sit. And some students are going to sit in the front and some students are going to choose to sit in the back. And lo and behold, I find the people in the front of my class make better grades than the people who sit in the back of the classroom. Now, have I proved that sitting closer to the board, that people can see better if they're at the front of the class? Is there any alternate explanation for why the people in the front of the classroom score higher on tests than people in the back of the classroom? My theory is that they see the board better. Can anybody think of an alternate explanation? And I'm going to wait in the chat bar because I know somebody can. So what's an alternate explanation for my data? The students who come in and choose to sit in the front of my class tend to make higher grades than those who sit in the back. And I assume that because of my correlational study, that it's because people can see the board better. Oh, wait a minute. The people in the front care more about the class. You're right. We probably have students. That's very good, AK, spoken like a true scientist. And you folks are saying that it's not that they see better, but they're obligated to pay attention more. Right. So all of those are great alternate explanations. And the reason it's occurred is because the students assigned themselves to the condition. Right? Now, in order to know, to really find out whether or not these students are the same, I need to use something called random assignment. Okay? And that is participants are placed randomly in their group. So, for example, in the study with the students, what I could do on the first day is I could randomly assign students the number. I could get a hat with a bunch of numbers written on a piece of paper, and those numbers could be ones or twos. I could have two groups, and half the class could be number ones and half the class could be number twos. I could put those ones and twos in a hat. I could shake those up, and then I could have my students pick the numbers out of the hat. Those students who get number ones have to come to the front of the classroom, and those who get number twos have to go to the back of the classroom. And therefore, some of my good students would be in the front, and my good students would be in the back, and some of my less responsible students would be in the front, and then they would be in the back. And so now, if I'm comparing the people in the front and the people in the back, they are similar at time one. They are randomly assigned, so those two groups are similar. What if I put all the males in the back and all the females in the front. That's going to be my assignment strategy. I don't have time to make out ones and twos, and I don't have a hat. So what I'm going to do is I'm going to put all the males in the back of the classroom and all the females in the front of the classroom. What's wrong with that assignment strategy? And lo and behold, I find that people in the front of the classroom make better grades than the people in the back of the classroom. What's the problem with that assignment strategy? Can anybody tell me? Is there some sort of difference between men and women that's not related to being able to see the board? Are there any other differences we might notice? While we wait for an answer, a disadvantage, there might be a disadvantage. See, the thing is, if we're going to do an experiment, we have to be comparing two groups which are exactly the same, Now, we can never be sure if two groups of people are exactly the same, but what we do is by randomly putting them into two groups, we give it the best chance of having two groups that have the same types of people. So if I randomly assigned you into two groups, we'd have some tall people in both groups. We'd have some short people in both groups. We'd have some average people in both groups. We'd have some males in both groups and some females in both groups. We'd have some students with high IQs in both groups. We'd have some students with average IQs in both groups. We'd have some nervous people in both groups, and we'd have some confident people in both groups. So if we do, and height, yeah, that's a great idea. Height. Maybe maybe if we put the females in the back, they can't see over the males because they're shorter. That's a great theory, but the point being is the two groups aren't the same at time one. So in an experiment, you get a group of people and then you divide them up using random assignment. Random assignment is the key to the experiment. And once we've created these two groups, we then manipulate a variable. So what we do is we give them both the same situation, but we change one factor we call the independent variable. The independent variable. So if I randomly assign you into group 1 and group 2 and put you in the same classroom, and I'm going to give you the same exact lecture with the same exact videos and the same exact PowerPoint, only some of you are going to sit in the front of the classroom and some of you are going to sit in the back of the classroom, right? Now, if I've randomly assigned you, I know that these two groups are the same and they should do well on the dependent variable, which is the exam. Now, if I set this experiment up and I randomly assign these two groups of people, I teach my lectures, and I then give them a test, the dependent variable, and I find that the group in the front scores higher than the group in the back, then I can say it's not intelligence that affects the grades. It's not sex or gender, right? It's not personality. The only difference in this whole situation was the fact that some people sat in the front and some people sat in the back. And this independent variable seemed to cause and affect a change on our dependent variable. Okay? And so now the experiment is the situation where we can begin to say that one thing causes another thing. Now, the disadvantage of the experiment is you have to create a really artificial situation in order to have enough control to use random assignment and to set up an independent variable. So experiments are sometimes very artificial and they don't look like the real world. And if you're testing something and you're testing it in a situation which is not like the real world, sometimes we don't feel confident that what you found in the laboratory will be the same if we go out and look at it in the real world. Okay? But the advantage of the experiment is it does allow you to say, in this particular situation, this particular variable caused a change on this other particular variable. Does that make sense? Now, I know it's probably hard maybe to understand this. Me talking, I'm probably not doing a great job. My PowerPoints may not be great. But if you will go to those resource videos that I told you about at the beginning of class, These resource videos will explain random assignment and will explain how to do an experiment to you in details with videos and animations, and I think you will find it very, very useful. All right, random assignment is the key to an experiment. If you don't have random assignment, you do not have an experiment. And random assignment allows the researchers to create two groups that are most likely equivalent at the beginning of the study. Now, it just might turn out that the two groups are different, all right? And statistics takes that into account, okay, with probability levels, okay? But random assignment gives us the best chance of having two groups that are most likely equivalent at the beginning of the studies. If the two groups are equivalent at the beginning of the study and everything about their situation is the same with the exception of one factor, then we know that any change in their behavior is due to that factor. So, how to create good random assignment in a class of 20 students? I might use a slip of paper with a 1 or 2 and have students pick slips of paper out of the hat to decide their group. You know what a bad way to do random assignment is? If I have 20 students come into my class, if I put the first 10 in group 1 and the last 10 in group 2, that's not random because the students are deciding in a pattern which group they're falling into. Maybe the best, most motivated students come to class the earliest, so they're all in group 1. And the laziest students come last, so they're in group 2. Maybe more females will come early to class than will males, so I'll have more females in one group than in the other. So if you don't use a random assignment method or you let the students choose their own group, you are not going to get random assignment, and your experiment is going to have what's known as an internal validity problem. An internal validity problem. You can't say that A causes B, right? Now, with an experiment and an artificial situation, you actually have what's known as external validity problems. This is not a methods class, so this won't be on your test. But an external validity is how confident that we feel what we found in this lab will really happen in the real world. And if you create a situation that's too artificial, people will say you don't have any external validity. Your findings probably wouldn't hold up in the real world. On the other hand, if you don't use random assignment, they'll say, uh-oh, you have an internal validity problem. You cannot say that A caused B this time. Okay? That's an experiment. Now, you know what? That's really all I have to say for today. Remember, there's the videos. In the course resources folder, there's a video on the steps in the scientific process that's going to reiterate what I talked about today. And then when we get to random assignment and experiments, I find that students have a little bit of difficulty with those. So I like to include a video, a resource video for each of these topics. Watch these videos. If you still don't understand what random assignment is, or how to set up an experiment and what an independent and dependent variable is, contact me and I'll be more than happy to walk you through this on my whiteboard in great detail. Research methods are always sort of a tricky thing to teach in one class period, and there are whole courses and whole books written on research methods. So it's hard to talk about it in one day and really teach people everything they need to know. But my idea is that you feel a little bit more confident. Hi, Nils. I'm in class right now. If I could call you right back. You're on YouTube. All right? I'll call you in a second. Hold on. Go ahead and say it.
Hey guys, what's up? What's happening?
This is.
How's it going? How's class with Dr. Roddenberry going? I'm sure amazing.
Thank you, Nils. That's Dr. Olson from George Washington University. He's a close colleague of mine and a good scientist, really smart guy. Oh, one last thing I do want to mention to you before I let you go. Holy cow, there's a section in your book on research ethics. Now, I didn't talk about it today in class, but research ethics are a very important part of the scientific process. We have to use informed consent. We have to make sure our participants know what they are doing, because some people have done bad things to people without their knowledge. We have to make sure that participants know they can quit the experiment at any time. We have to debrief students and tell them what we've done to them. We have to make sure not to harm our students. And another issue is we need to be honest in the research process. Absolutely. An internal review board, the IRB, John, is the board that what you do is you write a proposal, an IRB proposal, where you explain your entire research study. And the IRB board are a group of people who then go over your research study and make sure that you are not harming people, that you are not sharing people's private data with others, and that you are getting people's consent before you do this study, and people know what they're doing. But another thing that you have to do is you have to be ethical. Look at this thing. I've got this. I saw this amazing article. A famous honesty researcher is retracting a study over fake data. One of the colleagues that I knew from graduate school, a fellow named Dan Ariely. He's a very famous Duke researcher right now. I don't know if any of you have heard of the book called Predictably Irrational. Predictably Irrational. It was a New York Times bestseller. And I actually went to graduate school with this guy. He's become a very, very famous Duke researcher. And it turns out that a paper he published in 2012 contained fake data. They made up the data. And now this psychologist is in huge, huge trouble. And so they don't mention it, John, too much, but it's important that we also don't cheat in the research process. And there's a lot of pressure and money at stake. And sometimes researchers cheat when they do things. Okay, I've taken up enough of your time. I'm going to let you go. Remember, if you're coming to webinar, it is tonight at 8 p.m. and you can access it through Microsoft Teams. Log into Microsoft Teams using your WakeTech ID, and then click on the calendar and you will find the meeting event on your calendar for tonight. If you don't have any questions, I'm going to go ahead and shut down this broadcast and start preparing for my Psych 241 class. If you do have any questions, don't hesitate to send me a text or an email, and I will get back to you as soon as possible. Thanks everybody for coming today. Have a great day, and I will see you either tonight at the webinar or next Tuesday for class. Take care and have a great day.